Hello everyone, my name is Aman Mithani, and today I'll be presenting my midterm report for the course Introduction to Systems Engineering. The title of my project is a systems engineering case study of the F-35 Lightning II Joint Strike Fight program. And this program represents one of the most ambitious, complex, and costly engineering undertakings in modern history, and it serves as a fascinating case study for systems engineers just like us. So let me begin with some background. The F-35 program, also known as the Joint Fighter Strike Program, was conceived in 1990s and awarded in 2001 to Lockheed Martin. Its central idea was to create a family of aircraft that could serve multiple U.S. military branches, the Air Force, the Marine Corps, and the Navy, as well as allied nations. Instead of developing three separate aircrafts, the Department of Defense envisioned a single baseline that could be adapted into three variants: the F-35A, the Air Force, a conventional takeoff and landing aircraft to replace the F-16 and the A-10. The F-35B for the Marine Corps, featuring a short takeoff and a vertical landing to replace the Harrier jump jet. And finally, the F-35C for the Navy, designed for carrier operations with larger wings and reinforced landing gear. This approach promised cost savings by sharing parts, logistics, and trading pipelines. But it also introduced a new level of technical and organizational complexity that had rarely been seen in aerospace. From stealth features to advanced sensor fusion, and from international partnerships to more than 8 million lines of mission-critical software, the F-35 became the definition of systems of systems. So now let's walk through the concept development stage, which in systems engineering includes needs analysis, concept exploration, and concept definition. So the needs analysis. The Department of Defense from the US military faced an urgent problem. Its existing aircraft were aging, costly to maintain, and not fully compatible with the emerging doctrine of network-centric warfare. Each service had different mission needs. The Air Force wanted agility and precision strike capability, while the Marine Corps wanted vertical landing and capability for austere bases, and the US Navy finally demanded a long range of strike fighter tough enough for carrier landings. And adding to the complexity, allied nations wanted technology access and industrial participation, while the US sought to safeguard sensitive intellectual property. So even at the early stage, the program was in negotiation as much as a design exercise. Next, we talk about the content exploration. Engineers and policymakers consider three paths: separate aircraft for each service, incremental modernization of existing fleets, or the joint fighter concept, which is a shared baseline with variants. The third option was finally chosen, largely because of budget and political considerations, even though commonality of 70 to 80% across variants was technically unrealistic. The concept definition. Now, as we go towards concept definition, we realize that the stage formalized the F-35 vision, a fifth generation stealth aircraft combining multi-role flexibility, situational awareness, and interoperability. Key elements included stealth shaping, a powerful new engine, integrated radar and infrared systems, a helmet-mounted display, and of course, all the ALIS logistics backbone later replaced by the Odin. The lifecycle vision was bold, a 50-year lifespan, 50 plus operational years lifespan with continuous software and hardware upgrades, almost like an iPhone that keeps receiving updates. We then move on to the challenges. So no case study of the F-34 is complete without addressing the challenges, technical, organization, and even programmatic, that plagued the program. So let's see the challenges faced by the F-35 pilot. First, the decision to adopt concurrency. Producing aircraft while testing was still underway led to hundreds of jets that needed constant and costly retrofits. The undermined trust and balloon costs, which is very expensive. Second, software complexity became the pacing element of the program, with millions of lines of code and dozens of interacting systems, while verification and integration dragged on for years. And third, subsystem integration, particularly sensor fusion, was groundbreaking, but very difficult to implement in real time. Stealth materials also proved fragile and costly to maintain. We also saw organizational challenges. The program also suffers from organizational and stakeholder complexity. The Marine Corps STOVL requirement forced design compromises that hurt Air Force and Navy performance. Also, multinational collaboration introduced friction. Partners wanted access to stealth and avionics technology, but US exports controls were restricted sharing. This led to delays and disputes. Finally, the vast industrial network with Lockheed Martin and other top and at the top and hundreds of subcontractors worldwide created supply chain bottlenecks, quality issues, and also integration risks. Finally, the organized system became almost as complicated as the aircraft itself, which we can see. Then let's talk about the programmatic challenges. Beyond technical and organization hurdles, the F-35 was designed by persistent programmatic challenges. Those tied to cost, schedule, and sustainment and political realities. The program budget is perhaps the most infamous challenge, originally estimated at $200 billion. The cost ballooned over 400 billion for development and procurement, which sustained project at 1.3 trillion. Schedule delays meant the F-35 entered service years late, forcing the military to keep legacy fleets in operation. Then there were sustainment issues. The ALIS logistics system failed to deliver. The ALIS logistics system failed to deliver on its promises, grounding aircraft and frustrating users until Odin was introduced as a final replacement. Finally, political constraints made the program essentially too big to fail. With allied nations already invested and tens of thousands of jobs tied to production, cancellation was never an option, even in the face of cost overruns and performance shortfalls.